Welcome. Today we will be talking about our latest sales tool, the Bearing Lubrication Quick Reference Guide. We are going to learn how to walk through the latest Quick Reference Guide, which will show us how to select the correct grease, select the correct quantity for initial fill and regreasing, select the correct frequency of greasing, as well as also understanding the compatibility of different grease types.
So let's get started. So when we're using this chart, it's important that we have an understanding of the type of bearing that's in the equipment. Typically for electric motors, there's an electric motor plate which indicates the type of bearing that's used in that motor. By locating that reference number, we can Google search the bearing number, in this case an SKF 6201, and we can get the appropriate dimensional information that we'll use as we go through the Quick Reference Guide. For pillar block bearings, frequently we don't see the bearing itself, but we may see the bearing housing. And in this case, we see an SAF 520 bearing housing. So Googling that, we see the reference housing as indicated on the right side of the screen. And we also see something very important, and that is that the bearing contained in that housing can only be a 2220 EK bearing. By Googling that bearing reference number, we once again get the information for the dimensional data that we need to use the Quick Reference Guide. So let's take a look at a real situation. So in many cases, we have a fan or a blower where there is an electric motor driving the fan, and the fan shaft is supported by two pillar block bearings. In this case, we will use an electric motor bearing that is a 6312Z or a shielded ball bearing. The fan shaft is supported by a pillar block bearing that is a 22212E C3 fit or spherical roller bearing. The RPM of the fan is 750, and the service condition is occasionally wet with some vibration due to fan imbalance and moderate amount of dust and dirt on the bearing housings. We now can Google search the 22212 EK bearing, and we see that this spherical bearing has a shaft diameter of 60 millimeters, a bearing bore diameter of 110 millimeters, and a bearing width of 28 millimeters. When we search for the electric motor bearing, which is a ball bearing, we likewise see that the bearing data shows that it's a 60 millimeter shaft, a 130 bore diameter or outer race diameter, and a 31 millimeter bearing width. We now can use this data to make the proper grease selection based upon the speed factor of that bearing, which utilizes the ID, OD, and RPM for that calculation. So in this case, we find that the roller bearing and the ball bearing have speed factors between 63,000 and 71,000 DIN. By using those reference numbers, we now can go to the grease selection guide and select the grease based upon the speed factors. In this case, you will see that there are many greases for this common bearing speed, whether it's 615, 625, 622, depending upon your environment and application. Once we have the correct grease, we now have to determine the amount of grease that goes in the bearing for the initial fill. This is hand packing the bearing. As you can see from the chart, based upon the speed factor, we move from, in this case, 200,000 DIN up to the white section of the chart, and it indicates that the bearing is hand-packed to 70% of the free void volume. In our case, where we had the speed factor between 63,000 and 73,000, it requires almost a 95% fill of the bearing free space. Next is how much grease do we actually put into the housing on the initial fill. And for pillow block bearings, it's rather specific. We fill the pillow block bearing based upon where the zerk fitting or grease port is located on the housing. For center fill bearings, in this case directly through the E channel on the spherical roller, we fill the bearing housing to 20% of the bottom housing volume. For a bearing that's filled on the side, that bearing housing is filled to a 40% level. And for bearings that are operated in very wet and contaminated conditions, we may have to fill the bearing housing to an 80% of its fill capacity. So now let's take a look at how much grease we need to use when we re-grease the bearing after a service life. As you know, the initial fill will only last so long, and then we have to replenish that grease. So replenishing of the grease is based upon the bore diameter, or the large diameter of the bearing, times the width of the bearing, times a factor of 0.005, which will calculate the grams of grease for replenishment. And in our example, the roller bearing requires 15.4 grams of grease for replenishment, and the ball bearing requires 20.2 grams of grease for replenishment. And certainly you can round those numbers to the next whole number and be perfectly fine. So now we have the correct grease, the correct fill volume of the housing, the correct grams of grease for replenishment. So how often do you have to re-grease? If we go to the frequency section of the guide, it's fairly straightforward. Using the chart, we select the RPM, and in our example, it was 750. We go up on the guide to position 2, where it intersects the shaft diameter, and then we move to the left to the A, B, C guides, which indicate the number of hours based upon the bearing type. A is for radial ball bearings, B is for cylindrical and needle bearing and roller bearings, and C is for this very special spherical roller bearings and tapered roller bearings. And as you can see here, when we intersect, we see that the spherical bearing needs to be lubricated every 900 hours in our example, and the electric motor ball bearing is lubricated every 7,500 hours. So it's good to write these values down, because now we have to go to the service condition and look at the grease correction factor based upon our actual operating condition. So in this case, occasionally wet, moderate load, vibration, dust and dirt, we find that the correction factor is 0.3 to 0.4, which means that our spherical bearing is actually re-lubricated every 270 to 360 hours, and the electric motor ball bearing is lubricated every 2,250 to 3,000 hours. So this is critical to adjust the theoretical re-greasing frequency to match the actual service conditions that the equipment is experiencing. And lastly, but certainly not the least important, is grease compatibility. As you can well imagine, there are often other greases that are in the bearing, and there is some concern over grease compatibility. What we have done with our greases is to do the necessary testing, and we have produced the chart on the back page, which indicates the level of compatibility for our greases based upon other grease thickener types. C is completely compatible. That's referenced in the green shade. A is acceptable, which means that there may be a slight thinning, but certainly not to be worried. It just requires that we observe that bearing for the first 24 hours to see if there's any exudate coming from or oil seepage coming from the bearing. And then I is it's incompatible. And in those cases, it requires the old grease to be purged from the bearing or cleaned from the bearing before introducing the Chesterton technology. So things to remember. One is that it is important that we gather as much of the equipment information as possible. The bearing RPM, the bearing dimensions, the shaft diameter, the service conditions, because all those come into play to determine the correct grease, the correct fill volume, the replenishment quantity, and the replenishment frequency. And certainly if you have any questions, you can always contact us back at the factory or have a discussion with your sales manager or contact us by email at lubricants@chesterton.com. Or you can reach us online through Ask the Expert at the link indicated below.